So hello everyone and welcome to this new video, and this video is all about PubSub. So in this video we will understand like what PubSub is used for. So PubSub is a GCP version of messaging queues, and in GCP it is working in the same way how it works in other services. So let's see like what it is in GCP. So in GCP, it's a real-time messaging service that lets applications send and receive messages asynchronously between independent systems. When we say independent systems, it means like two different services of GCP. It could be a virtual machine, it could be a bucket, it could be a uh, like a cloud function, or it could be external HTTP request coming inside the GCP service. So it actually, helps to integrate all the two or three different independent systems to work together. So I would say it's a fully managed, high scalable, and generally used through decoupled services in distributed systems. It also used to, create event-driven architectures. Event-driven. When we say event-driven, it means like when an event occurs, then there is some action to be taken. So this is how event-driven architecture works. So for every event, there should be some work to be done. And in this pub subs, there are two terms that come across is like publishers and subscriptions. So publishers are someone who are actually sending a message and to a topic. So sending a message, it is like a sending a request or sending something to a topic or to someone to tell someone I want this thing to be executed, and the someone what we talk topic will listen to that request and keep that request to itself. Okay, now comes in picture is subscribers. So subscribers also attached to the topic, and those subscribers are like listening and waiting for any message or any request that comes to topic. So once the topic has received the request, thus it will pass it on to the subscriber. So this architecture is generally called as event driven. So what happened? Event has occurred. So publisher has sent a message to topic. So something has occurred. So that's an event. Now when this event has occurred, what will happen? Then the subscriber are waiting and subscriber will do their things. So one event happens, subscriber had done their own thing. So this is how this whole architecture works. So it's like uh, in some cases, let's in microservice architecture, you have five or six services are trying to fetch some data from single service, and let's say there are millions of requests coming to that particular service. Then what will happen? Some of the services will get unanswered or maybe dropped or get 404 error, or maybe it could drop that request. But when we have PubSub, then what will happen? There is a topic who will store all the requests to its buffer, and now the subscribers, in this case the service who is responsible for giving the response, will pick every message one by one, or if there are multiple instances running of that that service, then all the instances will pick each and every message and respond accordingly. So not a single request will be dropped in that case. So this architecture works in this way, and that's why it is very robust system when we talk about microservice architecture. Now let's see the core concepts of the PubSub. So generally we have topic. We have just seen what topics are. So topics are something sitting between the publisher and subscriptions. Okay. So in general definition, we say as a named resource to which publishers send messages. Okay. So some message or some request has been sent by publisher, and that is sent to a topic. So topic holds that message. Now comes to the publisher. So publisher is someone who sends the message, who publishes the message, who sends the request. Okay. Now subscribers are those who consumes that message. Consuming a message means whatever publisher has sent to the topic, that message will be sent further for the execution. And who is executing it? The subscriber who is listening to the topic. Okay, so this is how a subscriber works. So a subscriber can pull or receive a message. So it can pull by its own by sending a request to the PubSub, or it can just wait and receive something, some message pushed in the topic. Okay, so this is how it works. And the subscription is nothing, just a link between a topic and a subscriber. So how a subscriber will wait for some message from topic, you have to link that subscriber to a topic, and that link is generally known as subscription. So that's how they all are linked to each other. And the message again can be a simple string, can be a JSON, can be a binary. It is not limited to particular format. It could be anything, but yeah, it cannot be something very large or very long. There's a limit. Okay, so some message, some JSON, some binary is sent to the topic by publisher, and subscriber waiting for something, waiting on that topic, will receive that message. So in a pub sub architecture, there could be a multiple topics, maybe a topic for registration, maybe a topic for sign up, maybe a topic for billing, and each topic has can have multiple publishers, and each topic can be have multiple subscribers linked to it. And subscribers are generally GCP services, can be functions, can be instances, can be a microservice. So they all are subscribers and listening to different topics to do their executions. Okay, so that's how this pub/sub works, and these are some core concepts of pub/sub. We have already understand the pull and push request. So pull is something subscriber explicitly request a message. So pull is something, let's say there is a microservice waiting for some message to be received to it, but it can also explicitly reach out to the topic and ask for message. So this is something known as pull. But push is something very a simple way, like they are subscribed to an endpoint, subscribed to a HTTP endpoints, and whenever a message is received at the topic, it automatically passes on to the subscriber. That is known as push. So the topic is pushing a message to the subscriber that are linked to it. Okay, now there are some key features that are important to understand. The first thing, at least once delivery. So each message whoso has come to the topic will be at least delivered to any subscriber at least one time. Okay, so any message that is any publisher has sent any message to the topic, it will eventually reach to a subscriber who is actually going to execute according to that message at least one time. So this is important. No message is going to be lost. Yeah, sometimes happens like they are went to dead letter, but again there's a provision, you can bring back from that dead letter to the queue, and again it can be processed. So this it's a possibility, but then it's also a solution. Now it's a scalable, it's durable, and we already seen like how it decoupled the architecture. So no one architecture is like interlinked, hardly interlinked to each other. And I have already just explained like what dead letter queue is. It's a queue where the failed messages are sent, and again they are processed from that particular dead letter queues. Okay, now let's talk about some common use cases. These are generally used in the microservices for creating a very decoupled architecture that is highly resilient, fault tolerant. You know, so that's important to use in microservices architectures. You can also use it to ingest logs, so you don't have to call an API every time. You just send the log to the PubSub, and PubSub has the responsibility to deliver that log to particular place. Then you can also use in the streaming pipelines. IoT devices are something that are really very effective when you have to push real-time data to the servers. So PubSubs are very good to handle millions of requests and in 1 second at a moment and at the real time speed. So that's how it's been used. Now let's take an example of a real world example. So let's say and this example is all about a booking of a ride. So here let's say a ride booking app publishes a ride request to a event ride topic. So I have created a ride. Let's say I have created a ride named topic. So ride topic is a topic, and application has sent a ride request to the topic. So what will happen that when this ride request has been received to the topic, now what it will do? So now this ride topic has been subscribed to three different services. First is the payment service, second is a driver matching service, and notification service. So once the ride requested event has been received to the topic with the name ride topic, subscriber payment service will receive that request and send a payment related information to the customer. The driver matching service, who will again subscribe to this topic, will do its stuff and matches a driver and sends back the response to the application like this is your matched driver. And then also the notification service will send SMS and emails like you are requesting a cab, and this is your driver information and this is your payment information. So these three things are happening at the same time but not linked to each other. It's just subscribed to a topic and all three services are doing their task simultaneously without interconnected to each other. So that's how this flow explains the beauty of PubSub. So I think that's much for PubSub, and I have given all the related informations like how PubSub works. Thanks for watching this video, and please like and subscribe my channel. Thank you so much for watching this video.